Hello, fellow viewers. You are all welcome back to Prof. 1 Tutorials. Today, we are going to look at another aspect under integration. Today, we'll be looking at the indefinite integral as well as the definite integral. So stay tuned and let's get started. Calculus, we are going to look at integration. Specifically, we are going to start with the indefinite integral. Under the indefinite integral, a question will be given where there will be no limit. And in that case, your final answer must contain the arbitrary constant. So let's look at some few notes here. With the indefinite integral, it has no limit. In view of that, it contains the arbitrary constant C. All right. So, for example, they can give you an integral of, let's say, ax exponent 3 dx. So when you look at what we have here, the integral sign has no value from the base as well as a value from the top. So there is no value here, there is no value here. That is what we call the indefinite integral. So the value below, we call it the lower limit. The value up there, we call it the upper limit. But from here, there are no limits. In view of that, after integrating, you have to add the arbitrary constant C. That makes it the indefinite integral. So let's say if a question like this is posed to you, then you are just going to repeat the term given, then you add 1 to the exponent, then the same exponent here will be repeated from the denominator. Then you don't forget to add the C, which is the arbitrary constant. So from here, we are going to get ax power 4 all over 4 plus C. So this is just an example on how the indefinite integral looks like. So let's look at some few examples and how we are going to solve them. So viewers, join me on the board. Example: integrate the following functions. We have the integral of 1 minus t all squared dt. So we have the integral with a big bracket t cube plus 3t squared minus 1 all over t squared or dt. I. We have x cubed plus 1 over x squared plus root x or dx. IV, the integral of 2x cubed minus 3x all over 4x or dx. V, we have brackets open 1 plus x all squared all over root x dx. Vi, the integral of root x plus 1 over the cubic root of x or dx. All right. So all of these questions we have on the board, they have no limit from the integral sign, and that is what we call the indefinite integral. So you are going to take the questions one by one, then we look at how we can solve them. So we are going to start with the first one. So the first question is the integral of 1 minus t all squared dt. All right. Now, when a question like this is given, the first thing you are supposed to do is to expand this bracket. So we have the integral of, now when we are expanding, I have a trick I normally use, for which I call it the SMS. SMS. With the SMS, the first S means square. So we will square the first thing. So when we square this, we still get 1. Then the M here, we call it multiply. So with the multiplication, we are going to multiply 1 by the negative t, which is minus t, times 2. So we have minus 2t. Then the last s we have here is also square. So we also call this one the square. So over here, we are going to square the last term. So when I square minus t, I'll get positive t squared dt. So this is just an expansion. So from here, I can now start with the integration. When I integrate 1, I'll get t minus. When I integrate the minus 2t, I'm going to have minus 2t power 2 all over 2. Because from integration, this one has an exponent of 1. So you just add 1 to it, which is 2. The answer you get here, you are going to use that same value to divide. So now let's integrate t squared. So I'll repeat my t squared. Then I'll add 1 to it. I have plus 1 all over the same thing here, which is 2 plus 1 plus c, which is the arbitrary constant. So from here, I am going to get t minus, from here, this will cancel this. So I have t squared. Then from here, 2 plus 1, I have 3. So plus t cube all over 3 plus c. And this will be the final answer for the question I. So now let's look at the II. So with the II, we have the integral of t cube plus 3t squared minus 1 all over t squared all dt. All right. So this is the second part. Now from here, we will first of all divide each term by the denominator. So we have t cubed over t squared plus 3t squared over t squared minus 1 over t squared all dt. So from here, we can simplify. Over here, the t, there are 2. So we have 2 here, we have 3 here. When they cancel out, it will be left with a t. Then this will also take off this. We have 3. Then 1 over t squared, we still have 1 over t squared. So we are going to get t plus 3 minus 1 over t squared all dt. So from here, we need to change this before we can start with the integration. So we still have the integral of t plus 3 minus. Now we can push the t squared up. The moment the t squared comes up, we need to negate the exponent. So we have t exponent negative 2 dt. So since we have this term here, we can now start with the integration. So we have t. T, it has an exponent 1. So we'll add 1 to it anytime we are integrating. Divided by the same thing we have here. Plus, when we are integrating a constant, we add t to it because we are integrating with respect to t. Minus t exponent negative 2. And because I am integrating this, I need to add plus 1 to it all over the same exponent neg 2 plus 1 plus c. So from here, we have t squared over 2 because 1 plus 1 is 2, 1 plus 1 we have 2 plus 3t minus, over here we are going to get minus 2 plus 1, we have t exponent negative 1 all over minus 1 plus c, which is the arbitrary constant because the integral sign has no limit. From here, this can cancel this. So we have t squared over 2 plus 3t plus t exponent negative 1 over 1, which is still power negative 1 plus c. Then the final answer is going to be t squared over 2 plus 3t. And here, we can change this one to fraction, which is the same as 1 over t plus c. And this will be the final answer for the second question. All right. So now let's look at the third question. I. We have the integral of 2x cubed minus 3x all over 4x dx. So this is the third question. So with this, before we can integrate, we need to divide through by the denominator. So we have the integral of 2x cubed over 4x minus 3x over 4x, still dx. Now 2 goes here 1, 2 goes here 2, and this x can cancel x cubed and it will be left with x squared. From here, this x can also take off this x. So now we are going to have x squared over 2 minus 3 over 4 dx. So from here we can now start with the integration. So now let's start. When we want to integrate x squared over 2, just as we normally do, we need to add 1 to this. Then what we are going to get here, we will use it to divide this whole thing. So divided by 2 plus 1, we have 3. Minus, when we are integrating 3 over 4, we are going to get 3 over 4x plus c, which is the arbitrary constant. So from here, we are going to get x cubed over 2 times 1 over 3, because this is over 1. So when this one changes to multiplication, then we need to reciprocate the other fraction. Minus 3 over 4x plus c. So from here, we have x cubed over 6, because x cubed times 1, we have the same x cubed. 2 times 3, we have 6. Minus 3 over 4x plus c. So this will be the final answer for this particular question. So we are going to look at the fourth example. IV. We have the integral of x cubed plus 1 over x squared plus root x dx. So this will be our fourth example. All right. Now, before we can integrate this, we need to change 1 over x squared in the straight form, and root x should also be changed to an exponent form. So we have integral of x cubed plus, when we have 1 over x squared, we can rewrite it as x exponent negative 2. So here we are bringing the x squared up, and in that case, the exponent needs to be negated. Plus, root x is the same as x power or dx. After changing everything like this, we can start with the integration. So let's integrate x cubed. So in integrating x cubed, you add plus 1 to it all over the same exponent, which is 3 plus 1. Plus, we are going to integrate x exponent negative 2. So we add plus 1 over the same exponent, negative 2 plus 1. plus, then from here we have x exponent half. So when we are integrating this, we add 1 to it, all over half plus 1, plus the arbitrary constant, which is c. So plus c. So let me bring the plus c here. All right. So we can now proceed. So from here we have x exponent 3 plus 1, which is the same as x exponent 4 all over 4. Then we have plus x exponent negative 1 all over negative 1. That's negative 2 plus 1. Then plus x exponent 3 over 2 all over 3 over 2 plus c, which is the arbitrary constant. So we are going to get x power 4 over 4. Then because this is divided by negative 1, it is the same as minus x exponent negative 1 plus, from here is the same as x cubed multiplying half. That is 3 over 2 is the same as this, divided by the fraction here, which is 3 over 2 plus c. So you are trying to tackle this from there. So we have x exponent 4 over 4 minus, we can rewrite x exponent negative 1 as 1 over x plus, then from here x cubed, which is multiplying an exponent half, is the same as root x cubed. And anytime a term is dividing a fraction, the division sign changes to multiplication, then the other fraction, we are going to reciprocate it. So it's the same as 2 over 3 plus c. So we have x power 4 over 4 minus 1 over x plus 2 times root x cubed. We have 2 root x cubed all over 3 plus c. And this will be the final answer. Viewers, if you find this video very educative and amazing, don't forget to like, and you can also share your comments in the comment section. We are going to look at the next example. V. We have the integral of 1 plus x exponent 2 all over root x dx. So this will be our fifth example. So from here, we need to expand the numerator. Then afterwards, we need to also change what we have here to an exponent. So we still have the integral of, so here we are still going to use the SMS. So the first s means we will square the first term, which is 1. Then the m we have in the middle means we are going to multiply 1 by x by 2. So 1 by x, we still have x times 2. We have 2x plus, then we square the last term, which is x squared all over. Then from here we have x exponent half or dx. When we get here, we are going to divide each term from the numerator by the denominator. So this is how it's going to be. So we have 1 over x power half plus 2x over x power half plus x squared over x power half or dx. So we need to simplify what we have in the brackets before we can start with the integration. So you have the integral of, we can easily change this one. So 1 over x power half is the same as x exponent minus half plus, now when I bring this x power half up, it is going to be 2x multiplying x power minus half plus x squared. So here I will still bring the x power half upward. It will also be multiplying x power minus half or dx. So I still have x power minus half plus 2. This x is multiplying x power minus half. And over here, we are going to apply indices. So when two terms are multiplying which has common base, we will maintain one of the base and we are going to add their exponent. So this one has an exponent of 1. So 1 plus minus half, we have positive half. Plus, over here, they are also multiplying. So we keep one of the base, which is x. Then we add the exponent. So we have 2 plus minus half. We are going to get 3 over 2 or dx. Since we have this term, we can now start with the integration. So when we are integrating x exponent minus half, then we add 1 to it all over the same exponent we have here, which is minus half plus 1. So we are moving on to the second term. So we have 2x power half all over. So we add 1 to this. We have the same thing as we have done here, which is also half plus 1. Plus, we have x exponent 3 over 2. So in integrating, we add 1 to the exponent. All over the same thing here, which is also 3 over 2 plus 1. Plus c, because the integral sign has no limit. So viewers, let's proceed. We have x minus half plus 1. We are going to get positive half all over the same thing here, which is positive half, plus 2x, and here we have half plus 1. We are going to get 3 over 2 all over the denominator will also be 3 over 2 plus, here we have x 3 over 2 plus 1. It will also give us 5 over 2. So we have exponent 5 over 2 all over 3 over 2 plus 1. It will also give us 5 over 2 plus c. So when you get here, we need to simplify them further. So we have x power half dividing 1 over 2, because it is dividing the fraction here, half, plus 2x exponent 3 over 2. It is also dividing the denominator 3 over 2, plus x exponent 5 over 2, also dividing the denominator 5 over 2, plus c. So from here, we have x power half times, now we need to reciprocate this fraction, which will give us 2 over 1, plus, we are going to do the same thing here. So we have 2x exponent 3 over 2 times 2 over 3. We are going to reciprocate that. Plus x exponent 5 over 2 times 2 over 5 plus c. So from here, we are going to evaluate them more. So from here, these two will multiply the x power half. So we are going to get 2x exponent half. Then 2x exponent 3 over 2 times 2. We have 4x exponent 3 over 2 all over 3. Because this whole thing has 1. So 1 times 3, we still have 3. Notwithstanding, this one is also over 1. In that case, x exponent 5 over 2 times 2, it will give us 2x exponent 5 over 2 all over the denominator, which is 5 plus c. So here we are going to rewrite them in the root form. So we have 2. Now we know that x power half is the same as root x, plus here we are going to have 4x cubed multiplying half, because it's 3 over 2, which is the same as 3 multiplying half all over 3, plus 2x exponent 5. So we always pick the numerator, multiplying half, because 5 times half is the same as 5 over 2, all over 5 plus c. Then we have 2 root x plus 4 root x cubed, because the exponent half will be the root, all over 3, plus 2x power 5 with root all over 5 plus c. And this will be the final answer. Now we are going to look at the next example. So let's look at the next example. All right, so this is the next example. So from here, before we can integrate, we need to rewrite them. So we have the integral of root x is the same as x exponent half, plus 1 over, this is cubic root of x, which is also x exponent 1 over 3, or dx. So we still have the integral of x power half plus, then we are going to push the x power 1 over 3 up, which will be x exponent negative 1 over 3, or dx. After rewriting them like this, then we need to integrate them. So when we are integrating, we have x power half plus 1 all over the same exponent, which is half plus 1. plus x exponent negative 1 over 3 plus 1 all over the same exponent, which is minus 1 over 3 plus 1 plus c, because it has no limit. So now let's proceed. So we have x half plus 1, we are going to get 3 over 2 all over half plus 1, we still have 3 over 2 plus x exponent minus 1 over 3 plus 1, we have 2 over 3 all over the same 2 over 3 plus c. So from here we have x exponent 3 over 2 dividing the fraction, which is 3 over 2, plus we also have x exponent 2 over 3 also dividing 2 over 3 plus c. So from here we need to simplify them further. So we have x exponent 3 over 2. The division sign here will change to multiplication times, then we are going to reciprocate this particular fraction. So it's going to be 2 over 3 plus x exponent 2 over 3 times, here we are also going to reciprocate this fraction, which is going to be 3 over 2 plus c. Then this times this, we have 2x exponent 3 over 2. The whole of this is over 1. So 1 times 3, we have 3. Plus, this is also over 1. In that case, 3 times x exponent 2 over 3, we are going to get 3x exponent 2 over 3 all over 1 times 2, we have 2 plus c. So now we need to write them in a root form. So here we have 2x cubed multiplying half. So always the numerator will be left with the x. So x cubed, then it's going to multiply 1 over 2 like this. All over 3 plus 3x squared. So here we are going to maintain the squared, okay, or the 2, multiplying, because the 3 is the denominator, so it will multiply 1 over 3 all over 2 plus c. So now let's look at the final answer. So we are going to get 2x cubed, then because it is multiplying power 1 over 2, it's going to be the root all over 3 plus 3x squared, because it is multiplying power 1 over 3, it is going to be the cubic root. So we have the cubic root. So that's the cubic root all over 2 plus c. And this will be the final answer for this particular question. All right. So viewers, we are going to look at the second part, which is the definite integral. Definite integral. With a definite integral, limits are given. So for example, this will be the integral sign, then the limit, we have limit from a to b, then the function f of x dx, where this a, we call it the lower limit. Then the one on top is called the upper limit. So here, this is the definite integral. So from here, limits are given. All right. Let's have some short notes. Definite integral are those in which limits are applied. That is the lower limit as well as the upper limit. So when you have integral from a to b f of x dx, so we have the function of b minus the function of a. I have made this one the capital F because we have applied the integration, or we have integrated the function. That is why I've made it capital. So here we can say that definite integral from a to b. So from a to b, because this one is lesser than the one on top. All right, so we are going to look at some examples under the definite integral. Example: evaluate I, the integral from 1 to 2. We have x plus 1, x squared minus 2x plus 2 all over x squared dx. So viewers, let's get started. I, the integral from 1 to 2, then we have x plus 1, we have x squared minus 2x plus 2 all over x squared dx. Now from here, before we can proceed, we need to expand the numerator. So we have x times x squared, we have x cubed. X times minus 2x, we have minus 2x squared. X times 2, we have 2x. Then this one will also multiply through. So 1 times x squared, we have x squared. 1 times minus 2, minus 2x. 1 times 2, then we have 2. All over the denominator, which is x squared. Still dx. So let's proceed. 1 to 2. So from here, we can group like terms. So we have x cubed, which is the first one. We have minus 2x squared. We also have positive x squared. then positive 2x, then we have minus 2x, then plus 2 all over x squared dx. Now when we get here, we can see that we can evaluate some of them. All right. So we have the integral from 1 to 2 in a big bracket. So we have x cubed. From here, minus 2x squared plus x squared, we are going to get negative x squared. 2x minus 2x is 0. So it will be left with a positive 2. So plus 2 all over x squared dx. From here, we need to divide each term by the x squared. So we have the integral from 1 to 2. Then we have x cubed over x squared. So this over this. Then this x squared. So we have minus x squared also over the same denominator, x squared, plus 2 over the same denominator, x squared, all dx. From here, we are going to simplify them. So we have from 1 to 2. Then this will cancel this. It will be left with only x. Because we have twice of the x here, but here we have 3. So it will be left with only x. But when it comes to the second term, the x squared here will cancel this. So we have minus 1 plus 2 over x squared, all dx. So we need to rewrite the 2 over x squared before we can integrate them. Okay, so we need to rewrite the 2 over x squared before we can integrate. So we still have the integral from 1 to 2. Then we have x minus 1. Now we know that 2 over x squared is the same as 2x exponent negative 2 dx. So when the x squared is moved up, we are supposed to negate the exponent. Since we are able to rewrite everything like this, then we can now start with the integration. When we are integrating x, as we normally do, it already has an exponent of 1. So we are supposed to add 1 to it, all over the same exponent here, which is 1 plus 1, minus, when we are integrating 1, we will get x, plus, we need to also integrate 2x exponent negative 2. So when you're integrating this, we add 1 to the exponent divided by the same exponent here. But this time around, we are not going to add plus c to it. Why? Because it has limits. So we need to introduce their limit here. And this is the upper limit, and this is the lower limit. So let's proceed. From here, we are going to get x squared over 2 minus x plus 2x exponent negative 1 all over negative 1. Because minus 2 plus 1 we have negative 1. Then minus 2 plus 1 from the denominator, it is also negative 1. We still have our limit 2 and 1. All right. We still have x squared over 2 minus x. Then, because this is dividing the negative 1, it is going to affect that term. So it's going to be minus 2x exponent negative 1, then 2, 1. All right. So we still have x squared over 2 minus x minus. We can rewrite 2x exponent minus 1 as 2 over x. Still applying the limit from 1 to 2. So now this will be the integral, or after integrating, this will be the answer. But because of the limit, we need to make substitution in this function so that we can get our final answer. So first